Today we will discuss about what is meant by law of conservation of angular momentum. Law of conservation of angular momentum. Law of conservation of angular momentum. So what it says? Law of conservation of linear momentum, what it says? In the absence of external force, net linear momentum is constant. No? Same way we can write. We know that torque is equal to dl by dt. So if external torque is 0, if external torque acting on an object is 0, the total angular momentum remains constant. If external torque acting on an object is 0, its total angular momentum is conserved, and that is known as law of conservation of angular momentum. So what we can write? Torque is equal to 0, which means dl by dt is equal to 0 or n is equal to constant. Similar to conservation of linear momentum itself, there external force is 0. So total linear momentum is 0. This also conservation also we discussed when we discussed about rotational equilibrium. An object is said to be in rotational equilibrium if the net external torque acting on the object is 0. Okay. So angular momentum is constant. So what we can write? Angular momentum can be written as moment of inertia into angular velocity. So I omega is equal to constant. Or we can write I1 omega 1 is equal to I2. I1 omega 1 is equal to I2 omega 2. So that in the absence of external torque, total angular momentum is constant. Okay. So in the case of planets, planets are revolving around Sun not in circular orbit, in elliptical orbit. So whenever the planets are coming closer to the Sun, here Sun is here. So planets are revolving around the Sun in elliptical orbit. So here Sun will be at one of the foci. Okay. For example, if Sun is here. So if the planet is far away from the Sun, what happens? Moment of inertia increases and hence angular velocity decreases. And when it comes closer to the Sun, what happens? Moment of inertia decreases, so angular velocity increases. Okay, so we can write when planet is closer to the Sun, I decreases. Why I decreases? The perpendicular distance between Sun and planet decreases. No, I decreases. Hence omega increases. I decreases means moment of inertia decreases and hence omega increases. And if the planet is farther away from the Sun, what happens? When planet is far away from the Sun, I increases. And hence, so omega increases because of conservation of angular momentum. Similarly, if a person is standing on a rotating table, he can increase or decrease the speed of the rotating table by stretching his arms. If he stretches his arms, what happens? Moment of inertia increases, automatically angular velocity of the rotating table decreases. to the chest, what happens? Moment of inertia decreases and hence angular velocity increases. Similarly for skating, those who are doing skating and ballet dancers also, they can also increase the velocity by stretching their arms and by bringing arms closer to the chest, but they can vary the angular velocity, all because of law of conservation of angular momentum. So law of conservation of angular momentum, very simple. Angular momentum is constant in the absence of external torque. So we can write product of moment of inertia into angular velocity is constant. So at any instant, if I1 is the moment of inertia, corresponding angular velocity is omega 1. And after some time by stretching hand over different cases, okay, I2 is the moment of inertia, corresponding angular velocity is omega 2. We can write I1 omega 1 is equal to I2 omega 2, and that says law of conservation of angular momentum. Now we will discuss some problems related to conservation of angular momentum. If the earth were to suddenly contract to half of its present radius without any external torque on it, by what duration would the day be decreased? Assume that to be a perfect sphere of moment of inertia. If it is not given, also if it is given that it is a perfect sphere, you should know moment of inertia of a sphere about its axis of rotation is given by 2 by 5 m. Okay, so it is given. So how to find? It is given that without any external torque. So we can write angular momentum is conserved. So what we can write? According to conservation of angular momentum, we can write I1 omega 1 is equal to I2 omega. And angular velocity is also not given, but we know the relation between angular velocity and time period. So we can write first initial radius, that it be r, and that time taken, let it be what is the time taken? It is 24 hours. Okay, and I1 we can write it as 2 by 5 m r square, and I2 can be written as 2 by 5 m r square. We don't know. Okay. R1 is equal to R2 and R and R2 is equal to R2. So we have and T2 we have. And R2 it is given by what is R2? Assume contract to half of its present radius. So R2 is equal to, we can write what is the value of R2? R2 is equal to R1. So moment of inertia can be written as 2 by 5 m into r by 2 square. And we know the relation between omega and time period. We can write omega is equal to 2 pi by 2. So we can write I1 omega 1 is equal to I2 omega 2. So 2 by 5 m r square omega 1 can be written as 2 pi by T1 is equal to I2 2 by 5 m r by 2 the whole square into omega 2 is 2 pi by T. 2 by 5 m can be cancelled, but it is 2 pi can be cancelled, r square can be cancelled. So what you will get? T2 is equal to T1 into 1 by 4. R square, if you will get cancelled, you will get 1 by 4 only. R square also here, R square, this R square, and here also we can cancel. Okay. So T2 is equal to T1 into 1 by 4. T1 is 24. So 24 by 4 is equal to 6 hours is the time period now. So what it is given? Decrease in duration. Decrease in duration is given by 24 minus 6 is equal to 18 hours will be increased in the day. Okay, because time period now instead of 24 it will become 6 hours. So duration of the day will be decreased by 18 hours. Is it clear? And sometimes instead of giving the radius, they will give that volume is decreased to 1 by 4 or 1 by 6 like that. So in that case, what you have to do? You have to write mass equal to volume into density. No. Mass equal to volume into density. By using that, you have to write it. Okay. Density remains same by assuming that we can get the relation expression for what it is, radius. Expression for radius, second radius we can find in terms of first radius. Then you have to use conservation of angular momentum. Okay. Now we will discuss the next problem. Okay. The maximum and minimum distance of a comet from the sun are 1.4 into 10 raised to 12 meter, 1.4 into 10 raised to 12 meter, and 7 into 10 raised to 10 meter. If its velocity nearest to the sun is 6 into 10 raised to 14 meter per second, what is the velocity in the farthest position? Assume that the path of the comet in both the instantaneous position that is mentioned. In that particular instant, you can assume to be circular. Actually, it is not circular path, but that particular instant, we can assume it to be circular. Okay. Now, what we have to find? Same way, we have to find here also. We can assume angular momentum is conserved. So, I1 omega 1 is equal to I2 omega 2. I can written as mass into radius square. So, m r1 square omega 1 is equal to m r2 square omega 2. But you know the relation between linear velocity and angular velocity, v is equal to r omega. So omega is equal to v by r. So here you can write m into r1 square into v1 by r1 is equal to m into r2 square into v2 by r. M can be cancelled. Here 1 r1. So what you got? r1 v1 is equal to r2. r1 v1 is equal to r2 v2. So v2 you have to find r1 v1 by r. What is r1 v1? The velocity at the nearest position. Velocity is 6 into 10 raised to 14. That time what is which is the nearest position? It is 7 into 10 raised to 10. So 7 into 10 raised to 10. That time velocity is given by 6 into 10 raised to 14 divided by R2. R2 is 1.4 into 10 raised to 12. If you simplify, you will get it as 3000 meter per second. Okay, is it clear? And sometimes instead of this angular, the previous problem we discussed when time period is given. Sometimes instead of time period they will give frequency. So you should know the relation between frequency and angular velocity. What is the relation? Omega is equal to 2 pi. So by using this also you have to find. Okay. So whichever data is given, accordingly you have to convert this expression. What is the equation? Equation is saying only always angular momentum conservation only. Sometimes omega will be given directly, sometimes linear velocity will be given, sometimes time period will be given, and sometimes frequency will be given. So whichever is given, accordingly you have to rearrange this equation and to find the unknown quantity. Okay, is it clear? And now we will discuss about rolling motion. Rolling motion. So in the rolling motion, what is meant by rolling motion? We will have both translatory motion here, translatory motion and rotatory motion together is known as rolling motion. Okay. So rolling motion is a combination of your translatory motion plus your rotational motion. So if a disc or if a disc is rolling or if a wheel is rolling through the road without slipping. So what is meant by without slipping? Without slipping means that bottom which is in contact with the surface will be at rest. Okay, the bottom which is in contact with the surface will be always at rest. Whichever comes in contact with the surface will be at rest. That is what is meant by something rolling down without slipping. Okay, and now we will discuss about the solid cylinder rolling down an inclined plane without slipping. So here we are considering a solid cylinder rolling down an inclined plane without. What is the condition for without slipping? So theta is the angle of inclination. So mg is acting vertically downwards. So this angle will be theta. Mg cos theta is balanced by normal reaction, and mg sin theta is acting downwards. So net force can be written as what we can write. And what is F? F is the frictional force. Okay. So we can write net force is equal to F. Can be written as mg sin theta minus frictional force. Net force is equal to 1. Net force, what is net force? Mg sin theta is acting downwards. Frictional force is acting upwards. So mg sin theta minus F is equal to net force. Okay. And this frictional force helps for, or it is providing the torque which helps to rotate. Okay. So without slipping, it helps to rotate. So frictional force, we can write torque is equal to frictional force into R, where R is the radius of this. Okay. So that R is the radius. So we can write torque is equal to F into R, and that can also be written as I into alpha. Okay. And alpha can be written as, we know that B is equal to R omega. Same way A is equal to, we can write R. Or alpha is equal to A by R. Here R, capital R is the radius, so alpha is equal to A. So what we can write? F into R is equal to I into A by R. So the relation between linear acceleration and angular acceleration. Or we can write F is equal to IA by R. So that we can substitute in equation 1. So substituting E1. What you will get? F is equal to mg sin theta minus IA by R square. And instead of F, we can write it as mass into acceleration. So ma is equal to mg sin theta minus IA by R square. M can be taken to RHS. So what we will get? A is equal to g sin theta minus Ij by mr square. We can find acceleration. For that we can take to this side. What you will get? A into 1 plus I by mr square is equal to g sin theta. Or acceleration can be found out. G sin theta divided by 1 plus I by mr square. And moment of inertia of a solid cylinder about its axis is given by, we can write I is equal to half mr square. Now we can write moment of inertia of a solid cylinder about its axis. Half mr square. So that you can substitute here. So what you will get? Acceleration is equal to g sin theta divided by 1 plus half mr square divided by mr square. What you will get? G sin theta by 3 by 2. It is equal to 2 by 3 g sin. So this is the acceleration with which it is coming down. So you can see that it will be less than acceleration due to gravity, because maximum value of sin theta is 1, then also you get 2 by 3g only when it comes vertically. Okay, so acceleration of the cylinder when it is coming down an inclined plane will be always less than acceleration due to gravity. Now you can substitute in this equation, which equation? In this equation, in this equation itself, and you can find for frictional force. What you can write? Is it clear? Is it clear? No. So we can substitute. We can from equation 1 we can write. So from equation 1 we can write F is equal to mg sin theta minus F, or that can be written as mg sin theta minus m into mg sin theta, m can be taken common, g sin theta minus a can be written as 2 by 3 g sin theta. So you get frictional force as 1 by 3 mg. You got frictional force 1 by 3 mg sin theta, and you know the normal reaction mg cos theta. Now you can find coefficient of friction. Coefficient of friction is equal to F by N, normal reaction, and F is 1 by 3 mg sin theta divided by N is mg cos theta. We will get mu is equal to 1 by 3. Mu is equal to 1 by 3 tan theta, which means if coefficient of friction is greater than or equal to 1 by 3 tan theta, we can say that it will avoid slipping, otherwise it will slip. Okay, so this is the expression. So from this we can conclude that if coefficient of friction is greater than 1 by 3 tan theta, greater than or equal to tan theta, it will avoid slipping, otherwise it will slip. Okay, is it clear? So this is the expression for the coefficient of friction and acceleration, all those whichever is asked accordingly you can find it. And sometimes what happens is that they will ask which will reach with a greater velocity, like that will be discussed. Okay, kinetic energy of rolling motion. So in the case of kinetic energy during rolling motion, we can write total kinetic energy is equal to translational kinetic energy plus rotational kinetic energy. And translational kinetic energy is written as half into mass into velocity of center of mass square, plus rotational kinetic energy is written as half I omega. And moment of inertia can be written as mk square. Moment of inertia is equal to mass into radius of gyration square, and k is radius of gyration. So whenever you are writing any equation, you have to mention which are those mass. M stands for the total mass, V is the Vcm is the velocity of the center of mass, I is the moment of inertia of the object, omega is the angular velocity. Again you can find omega. You know the relation between omega and V. V is equal to R omega, or omega is equal to Vcm by R. Instead of omega, Vcm by R you can write. So that you can substitute here. What you get, kinetic energy is equal to half m Vcm square plus half, instead of I we can write mk square, instead of omega we can write Vcm by R, but it can be written as half m Vcm square plus half m Vcm square k square by R. So half m Vcm square can be taken common. 1 plus k square by R square. So this is the kinetic energy associated during rolling motion. Rolling motion means it will be rotating and it will be always or continue, it will be moving motion. That type of motion is rolling motion, both translatory motion and rotational motion together it will be. Okay. So kinetic energy is given by half mv square plus 1 plus k square by r square, where k is the moment of inertia and kinetic, k stands for the kinetic energy. And sometimes in problems they will give question. Three objects are rolling down, one sphere, one cylinder, one hollow cylinder. Three are rolling down, which then it will reach the on an inclined plane, which when it reaches the ground level, which will be having highest velocity. So how to find that? You can write this is equal to potential energy. This can be equated to potential energy, and from this VCM can be written as VCM equal to, like that you can find it. Okay, and moment of radius of gyration for different object you have to find it. How to find radius of gyration of different object? Radius, for example, radius of gyration of a cylinder. How you can find? You can equate mk square is equal to half mr square. For a solid cylinder, moment of inertia about an axis is given by half mr square equal to mk square. From that you can write k square equal to r square. If it is a sphere, this is for solid cylinder. For sphere, how to find? Same way you can equate mk square is equal to 2 by 5 mr square. So k square, what you will get? 2 by 5 r square. Okay, so that you can substitute here, and kinetic energy can be equated to mgh. So mgh is equal to half m VCM square into 1 plus k square by r square. So from this you can find VCM. Velocity can be calculated for different objects, and by using that you can say that which will reach first or which will reach last, like that. In textbook that example is given, you can go through that example and you can try to solve it. If you couldn't understand, contact me. Okay, I hope all of you understood. So today we discussed about what is meant by angular momentum conservation. Then we will discuss about rolling motion and motion of a solid cylinder rolling down an inclined plane. I hope all of you understood. You can refer some more problems from textbook or reference book and you can solve those problems. Okay.